Good morning, students. In video number 20 of 8th class chemistry, we will continue with lesson number 7, hydrogen, in which we will discuss about laboratory preparation and chemical properties of hydrogen.
Let's start with the laboratory method. Principle: hydrogen is prepared in the laboratory by the action of dilute acids, maybe hydrochloric acid or sulfuric acid, on granulated zinc. We will not perform this experiment by using nitric acid, as oxides of nitrogen are formed. See the reaction. When zinc reacts with dilute hydrochloric acid, it forms zinc chloride and hydrogen gas liberated. Similarly, when zinc granule reacts with dilute sulfuric acid, it forms zinc sulfate and hydrogen gas will be liberated. Now see the procedure how we prepare hydrogen in laboratory.
Laboratory preparation of hydrogen. See the apparatus in the laboratory require wolf bottle, delivery tube, thistle funnel, water bath and gas jar. Hydrogen gas is prepared in the laboratory by the action of zinc granule with dilute sulfuric acid and hydrochloric acid. Dilute sulfuric acid or hydrochloric acid is poured through the thistle funnel in the Bunsen bottle or in the conical flask. Hydrogen from sulfuric acid or hydrochloric acid displaces and collects in the water bath, and then it is collected in the gas jar. Hydrogen is explosive in nature, so it is safer to collect it over the water. In the conical flask, zinc sulfate is left behind.
Why we prefer zinc to other metals? We can use any metal more active than hydrogen except lead for the preparation of hydrogen gas. But we do not use highly active metals like sodium, calcium, magnesium because these metals react too vigorously. Secondly, these metals are very expensive too. So, moderately we can use zinc and iron metal because these metals are suitable and cheaper. We do not use iron either because it forms some foul smelling poisonous gases of silicon, sulfur and phosphorus present in the impurity. So we prefer zinc for performing laboratory experiment for the preparation of hydrogen gas. Large scale preparation of hydrogen by two methods, the electrolytic method and the Bosch method. Electrolytic method already we have discussed in previous video. Now we will continue with the Bosch method. What it is? When steam passed over red hot coke, what is known as water gas is formed. Water gas is a mixture of mainly carbon monoxide and hydrogen containing some carbon dioxide. Red hot coke, capital C, steam H2O, when passed over it, we get water gas CO plus H2. Now water gas is mixed with excess steam and heated at 450 degrees Celsius. The mixture is passed over a catalyst consisting of iron 3 oxide mixed with some chromium 3 oxide. Carbon monoxide abstract oxygen from water to form carbon dioxide and release hydrogen gas. So carbon dioxide is removed from the mixture by dissolving it in water. Under pressure. And we know carbon dioxide is only slightly soluble in water but highly soluble under pressure. So carbon dioxide under high pressure, it will dissolve in water, and hydrogen, it is collected separately. Properties of hydrogen. Hydrogen is colorless and odorless, having no smell. That sort of gas it is. Secondly, it is lightest element. In the starting of this chapter, already we read. And the lightest gas known. It is 14.6 times lighter than air. Underline this line. Third, it is almost insoluble in water. That's why in Bosch method, we dissolve carbon dioxide in water and get hydrogen gas collected separately. Some chemical properties. Reaction with oxygen or air. When kindled with hydrogen, burns in air or oxygen to form water. A large amount of heat is produced in this reaction. So the mixture of hydrogen and oxygen may explode. Second chemical property, reaction with chlorine. When hydrogen kindled with chlorine, it burns to form hydrogen chloride gas. Also, a mixture of hydrogen chloride, when placed in sunlight, it explodes to form the same product. So, hydrogen chloride gas can dissolve in water to obtain hydrochloric acid. Reaction with sulfur. Hydrogen react with molten sulfur to give hydrogen sulfide gas, which smell like rotten egg. Reaction with nitrogen. Hydrogen react with nitrogen only under special conditions to form appreciable amount of ammonium. The ammonia gas is formed, in turn decomposes back to hydrogen and nitrogen. So this reaction occur both way. Such a reaction are called reversible reaction. And what are the special conditions under which this reaction occur? At 500 degrees Celsius, 200 atmospheric pressure, in the presence of catalyst iron, this reaction occur in nature. Reaction with some metal oxide. Metal oxide. When passed over some hot metal like zinc oxide, iron oxide and copper oxide, hydrogen gas converted them in corresponding metals like zinc, iron, copper. Oxides of metal like potassium, calcium, sodium and magnesium are not converted into metal. So these are reactions in which it shows zinc oxide, mean metallic oxide, when react with hydrogen gas, it forms zinc, metal and water. Similarly, when iron oxide react with hydrogen gas, in the presence of heat, it forms iron and water. Copper oxide, when react with hydrogen, it forms copper and water. But these four metals which are highly reactive metal, these metal oxides are not converted in form of metals. Hydrogen is a reducing agent. The addition of hydrogen or the removal of oxygen from a substance is called reduction. On the other hand, addition of oxygen or removal of hydrogen from a substance is called oxidation. Some substances which causes reduction is known as reducing agent, and substances which causing oxidation is called oxidizing agent. We already discussed chemical properties of hydrogen, in which we come to know that hydrogen adds itself with oxygen, chlorine, sulfur and nitrogen, and it remove oxygen from some metal oxide. These reaction already in chemical properties we have completed. Thus, hydrogen is a reducing agent. It reduces oxygen to water, chlorine to hydrogen chloride gas, sulfur to hydrogen sulfide, nitrogen to ammonia. Then it also acts like reducing agent. How we come to know? Because it removes oxide from zinc oxide to form corresponding metal, from iron oxide to form iron, from copper oxide to form copper. Similarly, from lead oxide to form lead. How we can test that hydrogen gas is present or formed after the reaction? So hydrogen burns with a characteristic sound or pop. This property is used to test hydrogen.
Note down some revision question for the practice. Question 1. Define reducing agent. Second, why iron is not used for preparing hydrogen. Third, which product is formed when hydrogen reacts with nitrogen under special conditions.